for those who just need a bit of a recap on how it works. So Pythagoras Recap. Okay, so the first thing is describing our triangle. So if I draw a triangle like this, right, Pythagoras always deals with a right angle. Okay. Now, an important part of a Pythagoras is to find something called the hypotenuse. The hypotenuse is the longest side, and it's always opposite the right angle. Okay, so we can see here that in this case the hypotenuse is opposite the right angle. Now we use a special letter for this. We use the letter C. Okay, so the hypotenuse always uses the letter C. Don't know why, but that's how it is. Now Pythagoras' equation looks like this. C squared is equal to A squared plus B squared. Now if you use a bit of algebra, you can rearrange it so either C, A or B as by itself. So I like to write these down. If you want to find C, the hypotenuse, use this rule. If you want to find A, use this rule. And if you want to find B, use this rule here. Now you might be wondering, we know what C is. C is the hypotenuse. What might A and B represent? You may already know, but these are the shorter sides of the triangle. So it doesn't matter what you make each one of these. Okay. Now in this case, let's label our triangle now. You might have this as being A here, and this as being B there, right? So in this case, this is one of our shorter sides and the other shorter side. Now, we're going to just go through some examples. Hopefully there's a nice little recap on how to do that. So here we go. We're going to go through a few examples. Excuse the triangles, they're a bit dodgy. So, first example, we want to find the unknown side. And it works like this. So, first step, you want to label your triangle. Second step, you want to use the formula. 3, the third step, you want to find the unknown. Okay, now in this in mind, we're going to go through these. So I'll just zoom out a little bit there. Here we go. Hopefully you can see that okay. So we want to find the unknown side here. Now, first thing, let's label that triangle. Well, this is always C, so I'm going to write C there. And we're just working on this one here. This is your turn. This side is A and this side is B. Now you can use other letters if you so wish. You can go, this one could be B and this one could be A, you'll get the same answer. So we've done step 1 there. Our next step is to use the formula. Now in this case here, what do we want to find? We want to find C. Now if this is the case, to find C, we're going to use that rule up here. To find C, we use this rule, okay? So C is equal to big square root, and then just go A squared plus B squared. Now we know that A is 5, and we know that B is 7. You plug it in like that. Now in this example over here, we're going to put this straight into our calculator. So obviously this isn't your calculator that you have, but use the square root button, and then we go 5 squared plus 7 squared, and then you'll see an answer pops up. So we've got C is equal to 8.6023 yada yada yada. Now most of the time they want to go to 2 decimal places typically. So we've done step 1, step 2, we've found the unknown, now let's go to 2 decimal places. So here we go, put a division here, we can see that the 2 here is not going to round up to 0, so we just keep it at 8.60. Now this could well be centimetres, we're not sure, it doesn't say, but if these are centimetres then you found the length of C, which is 8.60 centimetres. Next thing, what I'd recommend doing is doing a sanity check, okay? So, is 8.60 the largest of the sides? Yes, therefore we've got it, okay? So what I want you to do is pause the video, then we'll go through the answers for this one. Okay, so we're going to go through the answers. So what you should have is this. C is equal to square root of 4 squared plus 6 squared. You type that into your calculator over here, and we'll just delete that. So square root 4 squared plus 6 squared, and out pops 7.21. And we're not sure about our units, but we could practice putting some in, maybe millimetres there. And we can see that we've gone through all the steps there, and it seems sensible because it's over. We're going to move on to our second set of examples now, okay? And this one here is going to be finding the shorter side. Okay, so I'm going to draw 2 more, hopefully not as dodgy triangles. All right, so here we go. First step, like before, we want to label. Second step, use the formula. Third step, right, we want to find the unknown. And then fourth step, 2DP. Fifth step, we do a sanity check. And excuse the dodgy writing, I'm just basically copying down what we said before. So first step, we label, okay? So let's go through and do that. Well, this is always C, it's the hypotenuse, as it's always opposite the right angle. So we can see that there. And it doesn't matter what we call it, we could call this bottom one A if we wanted, and this one B, okay? Next step is we want to use the correct formula. So let's scroll up and have a look. We want to find B, so we use this formula here, okay? So here we go, I'm going to write the formula out first. We've got B is equal to square root, so 7 squared, actually I'll just write in the rule that we're using first, C squared minus A squared, then underneath I'll write the answer there. So C is 7 squared, and A is, apologies, I'm using the wrong rule there. I'm going to find B this time. Sorry if you're confused at home. That is better. Okay, chuck in the values. So 7 squared minus 3 squared, and then we put that into our calculator. Now you may know one different thing here is that we're taking instead of adding, and that's why the number gets smaller rather than bigger, because we're working from the hypotenuse. So A is equal to 6.32, you can see I've rounded that to 2dp. And then we could put some units into practice, it might be metres, we're not sure. Let's do a sanity check. Is 6.32 smaller than our hypotenuse or shorter? Yes, it is. So what I want you to do now is pause the video, have a crack at this one, and then see if you can get the answer correct. We're going to go through the answers now. First step, label. I'm going to call this one A, and therefore this will be, just to practice using the other formula. Doesn't matter if you did the other way. B is equal to, use the formula, C squared minus A squared, plug in the values, take the square root, and then we put that into our calculator. 10 squared minus 8 squared, and out pops a nice clean answer of 6. It could be centimetres, right? Now in this case here, this is called a Pythagorean triple. These are really nice And the nice whole numbers come out. There's a few. You may have seen one before, 3, 4, 5. Another one is 6, 8, 10. You might see a pattern between those numbers too. Okay, now we've done that, we're going to move on to an applied situation. So this is applied Pythag. For those of the lesson, they would know this one already. So we've got a situation we're going to have a look at. So let's say we have 2 skyscrapers. One is 50 metres tall. The other is 80 metres tall. Okay, and let's just say they are, let's go 25 metres apart. Okay, so a rope is attached to the roofs. How long is this rope? Assuming no slack. Okay, so here we go. We're going to have a crack at this question. Now, one of the best things to do is to get into a diagram to start us off. So we've got 2 skyscrapers. You might have like the ground there. One's 50 metres and the other's 80 metres. And then we've got a rope that's attached between them. So I'm just drawing 2 dots there, and that's the rope. And we're assuming no slack here, it's nice and tight. And we can put in our dimensions. So this is 50 metres, and this is 80 metres. We also know that the buildings are 25 metres apart. So we've drawn in our building. You can put in some windows if you like, or if you think the workers don't deserve windows, just don't put them in. The thing is, we want to know how long is this rope here? And we can call that X if you like, but how long is that rope that's hanging between them? Okay, and I'll just write this as a rope. So this one looks a bit tricky, but there's actually some Pythagoras hidden in there. Can you see it? Well, what you can do is you can break up this into a right angled triangle. Do you see how you can make a triangle out of this? Now we know that with Pythagoras, we can help find lengths when there's a right angled triangle. We also know that the base is 25 metres and that the height is 80 minus 50, which is 30 metres. So now we can work out the length of this rope. So what we do is we label the triangle, and we're going to switch to red now. This we can call A, this we can call B, and this we can call C, because it's the hypotenuse, opposite the right angle. Let's sub in the values. Use the right formula. C is equal to A squared plus B squared. Plug in the values. So A in this case is 25 squared, and B in this case is 30 squared. Then we just put this into our calculator. So here we go, 25 squared plus 30 squared, and out pops 39.05 metres. And that's then we can write a statement. The length of the rope is 39.05 metres. Great.